So previously we were here on this slide. We actually finished this slide previously, and I have to start from here. But there are some points which I assigned to you yesterday. So I saw them, and then I feel that I should have to clear these points to you. So we already discussed points on the slides up to this point, and now this is another one. And this is the topic of challenges in machine learning. So here, uh, this point is saying that an issue of overfitting and underfitting normally arise when you normally run your machine learning models. So what is this overfitting and what is this underfitting? So that is mentioned there. That is mentioned there. So first, what is overfitting? So you have a machine learning model. You run your machine learning model on the test data, and you already have the data on which you already have trained the machine learning model on it. So there is a training data. In data, when you normally collect the data, you normally divide the data into two divisions: training data and the test data. Training data you normally use to train your model, machine learning model. This is the data on which your model will get the training, and it will make itself mature. And then test data is the data that you will test on your model, and then you will report the results based on that test data. So if your model is performing good on training data but not on test data, then that is called overfitting. Okay? Then that is called what? Overfitting. If our model is what? Performing good on training data, but on test data, it is not giving us good results. Okay? Not performing good. So then it is called overfitting. And if our model is not performing good on training and performing good on test, then this is underfitting. Huh? This is underfitting. So these are the two opposite categories. And then another one is curse of dimensionality. So there is a topic that we will study that is called reduction of dimensionality, or how we can reduce dimensionality. I told you yesterday that dimensionality is the size of the number of features for your data that you have collected. So normally, when we normally select features, leave it what is feature. Feature is what I told you that feature is if you have a table with rows and columns, then the column headings are called features. For the beginning, I told you this definition of feature. But we will understand this feature definition when we will study vectors. Just wait for some or two lectures and then it will come. But for the beginning, feature is what? The column headings. If you have a table, then the column headings are what? Features. Or you can say normally a variable that can take multiple values is called a feature, but leave it. I can make these easy definitions for you to understand feature. So anyhow, so when you have many features in your data and some features are similar to each other, which is called redundant, or some features are repeated, and you have too many features in your data, then this is what? The size of the features is large. And when the size of feature is large, it will need more computation time to compute the things. It will need more computation time for your machine learning model to train. That's why it is called that it is a curse. that it is a curse that the size of number of features is too much, that the dimensional, and now the number, the size, the number of the features is called dimensionality. Okay, the size, the large number. For example, what is the dimension of array? You will give me that the size of my array is 10, huh? So this is what it means. So that is the same thing over. Curse of dimensionality means if your total number of features is huge, then it is a curse. Then it is a curse. So then what? This is an issue. This is an issue. This is a challenge when you are designing a machine learning model. So when you have a vector, and if in your vector, if the dimension of the vector is increasing or increased, or if you have a large dimension of vector, vector is what? I in the beginning I told you that vector is a kind of array. Okay, vector is a kind of array, and array has the dimension. You can also say. So anyhow, if the dimensions of the vector is large, then this is an issue. I know that there is a test here, huh? Yes. When it will start? Now I want to work on you can work. I have only 1 hour. It will be finished at 11. Okay, you can continue your work if you want. I will continue. You will continue. Okay, good. So only 1 hour. At 11, it will be finished. And I will leave the class at 10:50. At 11, yeah. So the curse of dimensionality. So when the dimension of the vector, when the size of the vector is large, then it is a curse. Then it is an issue. You have to reduce this dimension to get better results. To get better results. But if the size of the vector is large, then the data will be increased exponentially. Definitely, if the column headings are large, then each column heading has what? Multiple values in a table. Then the data would be large. And when the data would be large, it will need exponential time in computation. So this is also an issue. And other thing, difficulty in deployment. So when your model is ready for working, and then what he is doing? He is deploying his new software or whatever. So similarly, when your ML model is ready, how you can deploy this? This is also a challenge. This is also a challenge that you have to perform. So these are the different challenges. Now we can move to our actual topic, which is applications of machine learning. So now this topic is easy. You will see different applications where we can apply the machine learning models. So for example, the first one is emotion analysis. So through machine learning, if you have some text by different people, then we can, if you have a chat storage of different people, they are talking with each other or whatever, then you can easily identify from their text that they are happy, are surprised, are neutral, or they are sad, angry, scared, or disgust. So these are the different human emotions. Okay, so you can detect these human emotion. You can analyze these human emotions from the text easily through machine learning models. Similarly, sentiment analysis. What is sentiment? Sentiment normally means opinion. Okay, so here, for example, it is written positive, neutral, and negative. So if you normally have many websites for movies, and people are watching movies on those websites and giving their comments, and then what those websites are also doing this thing that they are processing or evaluating your comments through machine learning models and highlighting or identifying or calculating the ranking for that movie. Okay, and they are calculating your feedback, your comment, that though your comment can be positive about that movie, or can be neutral about that movie, or can be negative about that movie. And these comments are now called sentiment analysis. Your opinions which you are giving for those movies, now ML models can analyze them, and this is called sentiment analysis. If I will make them bold, then you can see here. So great service for an affordable price. This is one comment of one customer. We will definitely be looking again, booking again. So there would be some product or something like that. And this is the two comments of the customers, and these are positive customers about that product which they bought, huh? And similarly, neutral, which is what just booked 2 nights at this. This is a hotel, okay? These are the comments uh, for the rooms that normally customers can book in an hotel. So yeah, this just booked 2 nights at this hotel. So this sentence is not giving positive or not giving negative feel or sense. So that's why it is neutral. And similarly, horrible services. The room was dirty and unpleasant, not worth the money. So this is totally negative, huh? And then it is negative, but machine learning model. So what? So people are giving this feedback, but then you have developed a machine learning model which can which can analyze these comments, and it can classify them into positive, neutral, or negative. For example, if there is one room who is getting 5 positive comments by 5 customers, and other room who is getting 10 negative comments about, so by these positive, negative, and neutral comments, you can count them, and then you can rank those rooms, okay, which you can rank, and it will be useful for your business, huh? Now, no, the fourth one, another application, weather forecasting and prediction. Weather forecasting and prediction. So we can also use machine learning models to forecast weathers and then predict. Or you can say we can also use machine learning models to predict weathers. And this is just one figure is displayed here. Here, if I will make it bold, we don't have to go into details. This is just an idea. You cannot, or we cannot understand this picture until we understand those techniques which are coming next. So here, so these are different data that you are taking. You are taking images from the satellite, and then you have taking some reading from the radar. So you are taking the longitude and the latitude of those locations, which is in your images, elevation, height, date and time, target time, etc., etc. Then you are converting it into different timings. You are noting different timing from 0 to minus 90, and then you are applying convolutional downsampling. What is convolutional downsampling? I told you yesterday. Hovering over the image on different positions and taking values. So and then so we are performing these things on it, and then we are applying again convolution with the LSTM. LSTM is also a form of neural network, and this is called temporal encoder. After that, we are applying axial attention block. Attention block is another form of neural network in BERT model. Okay, in BERT model. But leave that it, what it is doing, leave that. Here, only simple idea is that we are taking some information, we are taking picture, we are taking longitude, latitude, we are taking different definitions, elevation, temperature, day, time, and then we are taking these images for many days. And in this way, we in our storage we have a history of different readings at different times. For example, I have a reading at maybe in the midnight when 00:30, and then I have a reading at 1 a.m., and then I have a reading at 1:30, then 2, 2:30, 3, 3:30. In this way, I have a huge data set even for 3 or 4 months. If you have the data for that, then based on that data, you can predict the weather forecasting for the next 7 days, for the next 5 days. This is what this picture is saying. This is what this picture is saying. This is what this picture is saying, that we are predicting something like that. Similarly, you can predict the stock market trend, that what is going on there through the machine learning model. And maybe you have seen now in your Android phones that you will see many stock related applications there for the prediction. And I have also one of my friend here in Saudi Arabia, and he is also doing the same thing there, huh? By using some developer from Pakistan, they are building some application for this stock market analysis that people can use uh, for their benefits. Okay, so you can also use machine learning models to view the trends, or to view, or to predict or forecast many things related to stock marketing. Similarly, you can do the speech synthesis by using the machine learning model. And this picture is simply saying it to you that here we have a some person is speaking something, so we have a sample of speech here, and then we have a database. Through that database, we are producing what? We are producing a automatic speech model. So now we are combining this model with this sample of voice here. And then here we have reading, narrating, and emphasizing. Reading, for example, I am reading text. This is reading. Huh? Narrating is just a little bit more explanation. If I am reading and also explaining something, so that is narrating. And emphasizing, yeah, when I am moving my voice, for example, this is the TV. So this is what I am emphasizing, huh? So this is emphasizing. So I have these different things there by using these things, and here I am inputting some text, and on this text, what I want to do, I want that my model will speak this text by using the voice of this user. Okay, again, I want that my model will speak this input text by using the voice of this user. And different reading, rating, emphasizing styles are already there within the model. So, and then we apply this over this input text, and then here we have that sample. We have that sample of this input text with the voice of this user into the form of this reading, narrating, and emphasizing all parts. This is speech synthesizing. Okay, this is speech synthesizing. Now, another application, speech recognition. This is example here. You are speaking, we are making the quality of the voice a little bit enhanced. So this is speech enhancement. Then we are extracting features, and after that, from the speech, if I am speaking, for example, if I am speaking the word, for example, here, prevention. So prevention. So there are three syllables in here. Prevention. Normally, when the sound starts and when end, this is called one syllable. So pre, when, pre, stop, when, second syllable, shun, third syllable. So that is called phonetic unit recognition here. So by looking at the syllable. So here we are checking, recognizing like pre, when, and shun. So and this is the acoustic model that we have, and then we are converting that speech into text. This is called speech recognition. This is called when you are converting the sound, the audio into text, that is called speech recognition. So this is an also one application of the machine learning. Similarly, customer segmentation, you can do the customer segmentation for the business industry. Huh? So what is customer segmentation? For example, here it is written demographic segmentation. In this demographic segmentation is one type, behavior or behavioral is another type, psychographic is another type, and they are different. What is demographic? If you divide customers with respect to age, gender, religion, like that, huh? So this is demographic. Segmentation means grouping, dividing into pieces, huh? Segment is a piece, huh? So you divide the customer into different pieces. So that's why that is called customer segmentation. And machine learning models can do this segmentation for you because clustering is there, huh? Clustering is there. Anyhow, behavior, behavior, behavior wise segmentation. So it can be your social interest, it can be your hobbies, huh? It can be your attitudes, different things. So that is the related to behavior. And similarly, psychographic. So there are some mixed concepts. It can be your, there are different kind of personalities, huh? I don't even know the names of those personality, A type personality and B type personality. This is the field of psychology. So you can categorize them through personality or something related to psychology. You can build something like that, and then you can segment them. So that is psychographic. Value based, according to the money the customer is earning, so that is value based. And similarly, geographic, area wise, region wise. Technographics, the customers who are using the different technology, mobile devices or apps, so division like that. Need based, okay, need based is also there. Yes, okay. Why you were doing like that? So I said yes. Okay. Firmography is according to the firms or the organization in which people are working are like that. So this is you can also do the customer segmentation through this machine learning, and you can all you we can also do object recognition. As you can see here, here is the picture, and machine learning model is identifying these different objects, that this is the lamp, this is some statue, or these are the peoples or whatever, and giving them different colors. So these things you already know. And similarly, you can detect frauds and you can prevent them through machine learning models in the banks. And similarly, we can recommend products. If we are running business, we can recommend products in our business by using these machine learning model. This is an example here, which you can see. Uh, this is how normally different uh, sale and purchase type websites are working on. For example, this is one customer. She viewed this laptop, the speakers, and this LED. She viewed these three, but and the system is recommending her a headphone and the laptop, which she already viewed, and she bought this laptop. So whatever action this customer has taken, that is stored in that machine, in machine learning model or in the database of the business. Maybe Amazon, you can consider Amazon. And now another customer, and he is viewing this LED and this headphone. So this customer is viewing headphone, and this is recommended to this customer, huh? So this is what normally our algorithms are doing. Anyhow, so but this customer is viewing this LED and viewing this headphone. But recommended is what? This speaker which this customer is viewing, that is recommended to this man. And the laptop, he's not viewing with this laptop. This laptop is bought by the other customer, but this is the recommendation of our machine learning model to this customer, these two, and he bought this speaker and he's storing this information. And if it is working, it is doing this thing again and again, and it will increase the sales, huh? And it will increase the sales. Anyhow, this is what the recommendation systems are working, and so on. And many applications in this way you can see, in which you can use your machine learning model. Now, this topic is a little bit serious topic, okay? The previous topic was just flattery or praising documents or praising information for the machine learning. But here, types of machine learning algorithm, here you are going to see what are the different major categories are the types of machine learning algorithms. So there are major four categories in machine learning models: the supervised learning, and then the unsupervised learning, and then uh, the semi-supervised learning, and then the reinforcement learning. So there are four categories, four major divisions in machine learning. So these are their names, and now we will go one by one in each, and we will see that what is that category and what is the further divisions of that category. And we will go one by one. So supervised learning is what? Before starting it, I will give you an idea that machine learning model is a program, okay? And that program will take the input, it will process, and then it will give you the output. The same program structure that you are already experiencing from the start. So now, but this input, now this program, that this input it will take, this input would be data that you collected for it. And this data can be divided into two parts. First is training, other is test. Training data is normally you will use for the model so that the model can get trained on that data. And then you will not use this data again. And then you will have the test data. You will provide this test data into the model, and you will calculate your results on this test data, okay? On this test data. Anyhow, now this term of data, training data, test data, it will come again and again. So that's why I explained it, okay? So it will come again and again. Anybody who has a confusion in training data and test data, let me know now. All the students have the understanding of training data and test data? Clear or not? Yes. Okay. So supervised learning. So this is the first major category of machine learning algorithms. First major category of machine learning models, you can say algorithms. So these models are these algorithms which is in this category. They will take the data. They will take the data sample, or you will say they will take the data. Data into what? The training data. They will take the training data because it is taking is input, training data. And it will take another thing that is called, sometime it is called associated output, sometime it is called labels of that data. Labels of data. For example, here, this is your model here. In this picture, this is your model, machine learning model, whatever the program that you have here. But before that, this is something that you have to do before that. So here you have that data. Yeah, here I am removing that label only, okay? This data is there, okay? Because this is different data. It can be images, it can be text, it can be audio, it can be video. This is a data and the labels of the data is not available. Labels mean what is the name of this one? This is rectangle or what? This is circle. This is pentagon or what? So I don't, so 1, 2, 3, 4, 5, 6 hexagon, not pentagon, okay? So this is, so the names of this data is not available. The names are called labels, okay? So in supervised learning, the data will be given and the labels, which are the label names of this data, are also given. For example, this is rectangle, this is circle, this is triangle, this is hexagon. These are the names, huh? So the data with labels would be given in supervised learning. Okay. In supervised learning, the data with labels. Labels means names of that data. So in supervised learning, the data with labels will be given. So these two things are input. And then our machine, these two things we will give to our machine. Okay. And then it will process. Actually this our machine learning will model will process this data with this name. It will process. And then this is the training phase, okay? This is the training phase of our model. Our model is getting training on that data. And then here our model is trained. The training phase is finished, okay? Training phase is finished. And now we are giving some test data. And this test data does not have names. We are giving some random data, huh? Test data. And this data does not have names. And then this model will do what? It will take this data and it will give us, it will predict that this is triangle and this is circle that you have given to me. Because our model has already get their training from this model. Because this is the data and these are the names of it. And here it is getting training on it. And training means now our model has the understanding that this data has what label, this data has what label. And if you will give them unlabeled data as a test data, it will give you the name of that person or the name of that data. And how this model is giving us these answers? Because we already gave them this data with the labels on which this model has obtained this training. Okay, we already trained our model on the things. So that's why we normally call these labels associated output, that this is our output and this is our output. So this is the basic difference between the supervised and the unsupervised. In the unsupervised, we have only the data without labels. And in supervised, we have the data and also the labels. And also the output which we want to get on the output phase of our ML model. So now I can, so it will take the data sample. What is data sample? Training data. The training data and its associated output. This one, or the labels. You can call it label or responses with each data sample. So this is the each data sample, huh? And you have the names it for. And I explained this figure. This explanation is much better than these two lines. And the examples of this supervised learnings are what? There are different techniques available for to do to perform different things, and these techniques are called k nearest neighbor. Here k is not mentioned. You can mention it. Okay, k nearest neighbor, naive Bayes algorithm. So these are the theory. Naive Bayes is the theory available. Bayesian theorem is available in stats. Decision trees. So these are the theories available. So these are the names of the algorithms, okay? Statistical theories are statistical algorithms. These are the names of the statistical algorithms that you can use in supervised learning to do what? To do this classification and regression. Later on, I will explain what this classification and regression is. We can use linear regression in supervised learning. We can use support vector machines. We can use neural networks in supervised learning. Now, this supervised learning is further divided into two categories, classification and regression. What is classification and what is regression? Classification is what? When the objective of your ML model are when you want to predict categories, or when you want to predict labels or responses, as you have seen here. These are the labels: triangle, circle. It can be 2, it can be 3, it can be 4, it can be 5. Okay. When it is 2, it 2 classes. When it is 5, it is 5 classes. When it is 7, it is 7 classes. So anyhow, so this is called classification. When you want to predict, when your objective or when the objective of your ML model is what? To predict categorical output or labels, or you can say when you want to predict categories or labels or responses given on the input data. That is called classification. Example is here. So you are giving emails to your system, your ML model, and your ML model is classifying the emails into two categories, that either these emails are spam or not spam. This is the visual output of your model, okay? Visual. But first it will handle the emails. And then finally, normally in Python, at the end, we are normally displaying the output into the form of these charts like that. But this is just a diagram, not chart, okay? You can also display, in Python, you can also display some line in between and then some dots here, green dots, which means these are not spam, and the red dots, which means that these emails are what? Spams. But here we have the proper pictures, okay? For better understanding. This is not the output of Python, okay? This is just a diagram. But if you want to take a output in Python through some chart, then you can draw the line and then you can draw the dots, points for the emails, which your model has classified as spam or not spam. This is what you can do. And here you are saying that you are considering some features here, some features, leave it. For better understanding, just take this spam and not spam class. And then what is regression? So this is the second category of supervised learning. When you cannot perform classification, then maybe you can perform regression. But how and when we can perform regression? When your data is continuous. When your data is continuous. What it means? Let's see that. Here in regression, the key objective is to predict output labels or responses. The same thing, output labels, responses. You want to predict that. But if your output label or responses are in continuous numeric values, only then you can use regression. Still, you didn't understand. I know that. Some of you didn't understand. Now you will understand when I will explain this picture. Suppose you want to predict the price of different houses, okay? And for houses, you built different features, size of the room, how many number of rooms, how many square or whatever. You have different features, huh? And then you collected this information in Medina for different houses. And then you found your data that each house has a different price, huh? And then you plotted all these houses here on the chart. So this is one house which has this is the line which is indicating that the price is increasing from here to here, huh? Along with the features. features are increasing. These are the houses, different houses. And here, when this line is going up, the features of that houses increases. One house has only 2 rooms, other house has 5 rooms. Huh? One house has only 1 bathroom, other house has 2 bathrooms, 4 bathrooms, more facilities. So when this line is going up, these features of the house are also increasing, and the price of the house is also increasing. And here, this is one data sample, one house. This is another data sample. And this house is at the lower position. So it means that features are less, price is also less. Huh? This house at higher position, it means features are high, price is also high. And these are the different data points that you plotted on this chart. And this data is continuous. Okay. Continuous means it is differing with each other with the features and prices. And when you have the data like that, you cannot do the classification. You can go for the regression. Okay. Then you can call it regression. So these are the two categories in supervised learning that you can perform by using these different techniques that you have seen here. K nearest neighbor, naive based decision trees, linear regression, support vector machines, neural networks. And now unsupervised. I told you the difference between supervised and unsupervised is only the labels. Okay. And here, this is your machine learning model algorithm. And here you are giving the data. So you are giving only the data, but you are not giving that it is apple and orange, huh? You are not giving them the labels. You are not giving the names of the data. So you are giving only the raw data. That is called raw data without labels. And then you are giving some interpretation of this data that, okay, apple cannot be fully round. Huh? It has green leaves, it has green colors. So these are the different things. These interpretations is called features, okay? Is again called feature. And for oranges, you can say it has more round shape, green leaf, orange color, or something like that. And if you have many more free fruits, then you have further features. Further, so this is called interpretation. You will interpret these different objects in the raw data. You will not give them names. You will interpret what are the properties of those things. Huh? Those properties is called interpretation. Your algorithm will take this raw data and interpretation, and it will process it, and it will learn automatically that orange will have these interpretations, apple will have these interpretations. By looking many times, apple many times, and interpretation many times, it will finally decide, okay, this is the apple, this is orange. So your algorithm will get that understanding after processing this raw data and the interpretation. Here we are, and when you will give some test, here there is no need to give the test data actually, because this whole is a data. We are not giving them the labels, we are not giving them the outputs. Huh? From this model, what we want that predict that what are these things, and this model is predicting that these are the apples and these are the oranges, classifying. Okay. And this model is automatically predicting that these are apples, these are oranges. How this model is predicting? Because you have given some interpretation of these things, of these fruits here, and your algorithm processed these objects with this interpretations, and now giving you the results by looking at these interpretations. Here you are not giving any labels here. So this is unlabeled data. This is the difference, only difference between supervised and unsupervised. So here the training data is what? Here we don't have any pre-labeled training data. No. This is raw data, not labeled data. And you can use what type of techniques? You can use k-means clustering. You can use k nearest neighbors and many others. You can use neural networks. Hmm.
Can you go back to the slide? Victor, here in the output, how it gives me the name of that class?
Apples.
Yes, because I didn't provide the labels.
So I provide these things here. For in interpretation, you will give this information that the apples can have what I was explaining. I was explaining in the beginning. Okay, first interpretation you will give that apple can have red color, green leaf, not fully rounded, partially rounded. Okay, and for orange you will say color. Okay, color is orange, leaf green. That the same, and the shape fully rounded or partially rounded. You can say more than partially rounded, huh? And in this way you can build these features. These I'm calling it interpretation, and then when you will have large data and your algorithm will see, okay, apple interpretation counted on this one count, another count, three count, and based on this count maybe it will count here color is different, so it will reject, huh? It will reject that this is not a count for the apple, this is count for. So based on this interpretation models, based on this interpretation your algorithm will learn automatically. Okay, will learn automatically, and after processing based on that evidence, that is a probabilistic model. It will calculate the probability that it is more based on different counts by total counts. How we can calculate probability? Probability has a formula. Okay, if you study discrete mathematics with me, I have mentioned those formulas there. Okay, so I'm not going to explain that what is the formulas for the probability. So probability, how you can calculate probability? You can calculate the probability on counts count divided by total, count divided by total, you will get the probability. So your algorithm is learning this thing automatically by counting, and by counting these interpretations. And these interpretations, you have provided interpretations for apple, for orange, for all other fruit that you have. And that's why on based on the counting of probability values of these objects, your algorithm is predicting that it is apple and orange. And
So the point here is that I will not provide training data with labels. I will only provide the input data, this data, with some features in the interpretation.
mm, yeah, yes.
Only for classification, or we can use it also for
This is not for classification. Oh, if you are asking that this classification, okay. But normally classification is a category that you use for supervise. Okay, so that's why I'm saying it is not classification. But if you are saying here we are making classes, okay, we are making classes. No, not only for classification. You can do different things. You can do clustering, which is close to classification. You can do association. You can do also dimensionality reduction. We can also use this for anomaly detection. So this is what we have to say after it. uh, but 11 has uh, okay, it's time is over, so I will stop and we will continue next from here, huh? From these divisions, okay? Inshallah. What is the section number?